The quest for extraterrestrial life has inspired countless science fiction stories and driven NASA missions. One of the most intriguing places in this search is Europa, a moon of Jupiter, which many believe could hold key insights about life beyond Earth. Bill Nye, the renowned science advocate, is among those pushing for further exploration of Europa, convinced that this celestial body may hold the answers to unlocking the mysteries of life beyond our planet. NASA's Voyager 1 spacecraft, launched in 1977, made a groundbreaking discovery outside our solar system that continues to capture the attention of some of the brightest minds, including Bill Nye. Voyager 1 identified ionized gas particles interacting in the region just beyond the heliosphere, the bubble-like area created by the solar wind. These findings provided crucial insights into the conditions that may exist beyond our solar system, and have raised questions about the possibility of extraterrestrial life. This question has fascinated scientists and space enthusiasts alike. Bill Nye has long been a prominent figure in the search for alien life, and his passion for the unknown is evident in his interviews and talks. He often emphasizes the importance of space exploration. The discovery made by Voyager 1 has only fueled this passion, providing new information that might answer the age-old question: are we alone in the universe? To understand why this discovery is so important, it's essential to revisit the early days of space exploration. Before the Voyager missions, NASA had achieved a major milestone by sending humans to the moon. This success sparked global excitement within the scientific community, and plans were soon underway to explore further into space. NASA's next goal was to study the outer planets of our solar system, but sending humans on such missions wasn't yet feasible. The vast distances and technological limitations of the 1970s meant that NASA had to rely on robotic spacecraft for these ambitious investigations. At the time, the Cold War was in full swing, with the United States locked in a fierce competition with the Soviet Union. This rivalry extended into space, where both nations sought to demonstrate their technological superiority. The Soviets had made early significant strides in space exploration, launching the first artificial satellite in 1957 and sending the first human, Yuri Gagarin, into space in 1961. However, the U.S. caught up with the Apollo 11 mission in 1969, landing astronauts Neil Armstrong and Buzz Aldrin on the moon. This was a turning point in the space race, but the U.S. knew it could not rest on its laurels. The competition with the Soviet Union continued to drive NASA's ambitions. NASA sought to go beyond the moon, aiming to explore the outer planets. The agency began developing spacecraft capable of traveling deep into space. One of NASA's early efforts was the Pioneer 10 spacecraft, launched in 1972, which became the first spacecraft to fly by Jupiter and send back pictures. Pioneer 11 followed the next year, also heading toward the outer planets. However, NASA needed more advanced spacecraft capable of capturing detailed images and data not just from Jupiter but also from Saturn, Uranus, and Neptune. This led to the development of the Voyager program. The plan was ambitious: to use a rare planetary alignment known as the Great Encounter to slingshot the spacecraft from one planet to the next using gravitational forces. This alignment, which occurs only once every 156 years, would allow NASA to study all of the outer planets in a single mission, saving both time and money. To achieve this, NASA built two Voyager spacecraft. Voyager 1 was designed to take a shorter route, visiting Jupiter and Saturn, while Voyager 2 would follow a longer path to reach Uranus and Neptune. On August 20, 1977, Voyager 2 was launched, followed by Voyager 1 on September 5 of the same year. These twin spacecraft would go on to make some of the most astonishing discoveries in the history of space exploration. Voyager 1 began capturing images of Jupiter on January 30, 1979, revealing details of the gas giant never seen before, including the Great Red Spot, a massive storm that has been raging for centuries. However, Voyager 1's mission didn't end there. After completing its flyby of Jupiter, the spacecraft continued on to Saturn, sending back even more remarkable data. One of the most significant discoveries made by Voyager 1 was the detection of ionized gas particles outside the solar system. These particles were interacting in the region beyond the heliosphere, providing valuable insights into what conditions might be like in interstellar space. As the Voyager missions continue to send back data from the farthest reaches of space, the search for extraterrestrial life remains as urgent as ever. Bill Nye and other scientists believe that exploring places like Europa, where a subsurface ocean lies beneath a thick, icy crust, could provide the next major breakthrough. What we learn from these missions could forever change our understanding of life in the universe. Every 96 seconds, Voyager 1 captured images and combined them to create a color stop-motion video. Using this technique, the spacecraft was able to send back footage showing 10 rotations of Jupiter. By February 10, Voyager 1 had moved into the planet's moon system, sending back images of regular moons orbiting the gas giant. Soon after, it discovered a faint ring of dust and ice surrounding Saturn, which was previously invisible from a distance. This showed that Saturn wasn't the only planet with rings. The ring, just under 30 meters in diameter, baffled scientists, as it indicated how little they knew about this planet. By May 5 of that year, Voyager 1 had its closest encounter with the gas giant, passing within a mere 174,000 miles. During this encounter, the spacecraft passed by several of Jupiter's moons, including Io, Europa, Ganymede, and Callisto. The images it sent back provided incredible insights into these strange moons, some of which were vastly different from our own. One of the more intriguing moons was Europa. With its smooth, icy surface covering a vast ocean of water beneath, many scientists believe that life could potentially thrive beneath the ice, making it a prime candidate in the search for extraterrestrial life. Holes found on the icy surface indicated past collisions with space rocks and smaller comets. Following this, images revealed what appeared to be the largest moon in the solar system, Ganymede. This moon is so large that it surpasses Mercury in size, with its own magnetic field. The images showed that its surface was mostly covered in rocks and ice, and Ganymede's complex geological history continues to puzzle scientists today. It's likely that Ganymede has a liquid core deep inside, responsible for its strong magnetic field. Another large moon captured by the spacecraft was Callisto, Jupiter's second-largest moon. Its heavily cratered surface revealed a history of frequent collisions with space rocks, along with a lack of geological activity. Like Europa, Callisto is believed to harbor an ocean beneath its surface, making it another candidate for extraterrestrial life. The spacecraft also discovered 2 new moons, named Thebe and Métis. The images suggested they are both small, irregularly shaped, and orbit much closer to Jupiter than other moons. It's interesting to note that both the planet and its satellites were named after famous mythological figures. Jupiter, named after the Greco-Roman god of thunder, is surrounded by moons named after characters who had personal interactions with him. After the spacecraft's encounter with Jupiter, a course correction was made to avoid it orbiting Earth endlessly, preparing it for a journey toward Saturn. About 6 months later, in October, another adjustment was made to avoid a potential collision with Titan, one of Saturn's moons. The encounter with Saturn was just as remarkable as the one with Jupiter. The spacecraft discovered 5 new moons, a ring system with thousands of bands, transient clouds made up of particles called spokes, and a previously unseen ring. It was also found that certain moons were responsible for maintaining the defined structure of Saturn's rings, which gives them their distinct beauty. In the weeks that followed, Voyager 1 captured stunning images of Saturn's moons, including Titan, Mimas, Enceladus, Tethys, Dione, and Rhea. These moons appeared to be mostly composed of ice, with potential oceans beneath, increasing the chances of extraterrestrial life thriving beyond Earth. One discovery that particularly excited NASA scientists involved Mimas, a relatively small moon with a unique feature, an enormous impact crater named Herschel. This crater made Mimas resemble the Death Star from the famous sci-fi series Star Wars. This intriguing characteristic indicated a significant past collision with a large space rock. Other moons observed by the spacecraft were mostly made of ice, with each having its own points of interest. However, perhaps the most fascinating discovery was Titan. Captured on November 12 from a distance of less than 3,000 miles, the images revealed a dense atmosphere that completely obscured its surface. The atmosphere, composed mainly of nitrogen, had a surface pressure similar to that of Earth at sea level, but with temperatures around -300 degrees Fahrenheit. These characteristics suggested that Titan might be the only body in the solar system besides Earth where liquid could exist on the surface. The chemical reactions necessary for the formation of life seemed present on this moon, with strong indications of essential hydrocarbons that are vital for life to occur. The spacecraft's closest encounter with Saturn was on November 12, passing just under 8,000 miles from the planet. By 1989, Voyager 1 had completed its planned exploration of all four gas giants, but the spacecraft was still operational. NASA then declared it part of the Voyager interstellar mission, which officially began on January 1, 1990. Its new goal was to travel beyond the outer planets and, if possible, into interstellar space. The mission aimed to gather data on regions dominated by Earth's magnetic and solar fields, as well as the interstellar medium. On February 17, 1998, Voyager 1 became the most distant human-made object, surpassing Pioneer 10 at nearly 70 astronomical units away. By September 2017, 45 years after its launch, Voyager 1 was still functioning, sending back data via its instruments to NASA's Deep Space Network. It was astonishing to scientists that its cosmic ray telescope and magnetometer continued to operate after more than 4 decades of travel through space. Now journeying into interstellar space, researchers hoped that something out there would eventually detect the message we had sent into the cosmos. Voyager 1 entered interstellar space in August 2012, marking humanity's first venture into this unknown region. This milestone gave scientists a unique opportunity to study conditions in space beyond the heliosphere, the protective bubble surrounding our solar system. Data from Voyager 1 has been instrumental in understanding the nature of cosmic rays, magnetic fields, and plasma interactions in interstellar space. Meanwhile, Voyager 2 continued its mission, eventually entering interstellar space in November 2018, providing valuable comparative data that further enhanced our understanding of the boundaries of the solar system. Both spacecraft carry a golden record containing sounds and images meant to convey the diversity of life and culture on Earth, a message to any potential extraterrestrial civilizations, expressing humanity's desire to connect with the universe. As the Voyagers continue their journey, they contribute to the broader field of astronomy by observing phenomena such as the interstellar medium, the local interstellar cloud, and the interactions between the solar wind and the cosmic environment. Their findings have provided insights into the structure of the heliosphere and the nature of the interstellar magnetic field. The data from both spacecraft is also critical for future interstellar missions. As technology advances, scientists and engineers are studying the performance of the Voyagers to develop new spacecraft capable of traveling even farther into space. This includes potential missions to nearby star systems or to investigate the boundaries of the Milky Way galaxy. The legacy of the Voyager missions lies not only in their immediate discoveries but also in their role as pioneers for humanity's deeper exploration of the universe.